Good day, students. On this clip, we're going to be going over some examples of factoring trinomials by grouping. This is part one of a three-part series to help you master the art of factoring trinomials by grouping. Okay, so let's take a look at the following examples. Yeah, before I actually start, I just want to go over the whole idea of factoring. So consider this. Let's say you have A times B plus change that color. So let's say we have A times B plus A times C. Alright? If I wanted to factor this, what would that look like? You notice that A and A are common on these two sides, right? So what is the whole idea of factoring mean? Basically means when I factor out A and A from this side, it's as though I were dividing these two by A. So when I factor out A from these two terms, it is as though, let me bring this A a little bit closer, it is as though I'm dividing the first term by A, and put it in the second term by A, and putting it out of there. Okay? And when I factor out A from this term and this term, they basically cancel out, and you're left with B plus, and this one, this cancel out C. Okay? And a way to check if your factorization is accurate is by distributing, right? So if I distributed this A to both of them, I'll end up with what I started with initially, A times B plus A times C. So what I just need you to remember is that anytime you factor out a common factor and it goes in front of the parentheses, whatever you have left, that factor term has to be gone. Alright, so if I factor out A, this A and this A are gone, and what's left is what comes down, B, the sign plus C. Alright, so factoring is the opposite of distribution, so keep that in mind. Alright, so with that fact in mind, let's try out some examples. Instructions are to factor the following. Factor the following expressions, okay? We're going to start by doing really easy process ones, and then in the subsequent parts or installments of this video, we're going to start attacking some really complicated problems, alright? So from number one, we have y times y plus 4 plus 5 times y plus 4. Okay? Now if you look at these two, what do you notice? You notice that y plus 4 is common to these two terms right here. The terms are separated by a plus. So y plus 4 is common. So what am I going to do? I'm going to take this y plus 4 and this y plus 4. Since they're common, I'm going to factor them out. Remember, after you factor them out, I'm going to factor them out as 1 since they're common. That means is whereas though I divided this term and this term by y plus 4. Okay? So this whole term I divide by y plus 4, and this term I divide by y plus 4, and I factor them out as 1. So what does that mean? It means that whatever I bring down, this y plus 4 and this y plus 4 have already been factored out. So they're gone. So I'm just left with y plus 5. Okay, so y plus 4, I'm sorry, this needs to be in parentheses. So this is the factored form of the original expression I showed you. Okay? Alright, let's take a look at another example similar to this. Number 2. What if I had m times n minus p minus q times n minus p? Well, what do you notice here? You notice that n minus p is common on both. They're common on both sides of the term. So this n minus p here and this n minus p are both common. So what do you do with common factors? You factor them out as 1. So this n minus p and n minus p, I'll factor it out as 1, n minus p. And it was as though I divided this term and this term by n minus p. So after factoring it out, guess what? This and this are both gone. And what are you left with? You're left with m and my negative q. So in this parenthesis, what's left after you factor out the common terms is m minus q. Alright? So there goes your answer. The more of these problems you do, the better you get, so you can do a lot of these steps mentally. You don't have to actually write it down. Alright? So let's try another example. Example 3. So for example 3, we have 3a 3a times b minus 4 plus 2 times b minus 4. So let's take a look at this carefully. If you notice, b minus 4 is common on both sides of this plus sign, right? So b minus 4 and b minus 4 are both common. So what do you do with those two common factors? So they're common factor, you factor them out as 1, b minus 4. Remember, when you're factoring something out, it's as though you were dividing. So when you divide it out, it's gone. So these two are gone, and what are you left with? You're left with 3a and positive 2. So you're going to be left with 3a plus 2. Okay, so this right here is the factored form of the original expression. Alright, number 4. Let's try this out. What if I had m times n plus p minus n times n plus p? Now what do you have in this case? You can see that n plus p is common on the left side and the right side. So what do I do with it? Since they're common, I factor it out as 1, n plus p. And remember, anything you factor out is cancelled out because it's whereas though you're dividing the original expression by that common factor. And what are you left with? You're left with m and negative n. So it's m minus n. So this is a factored form of what you have on the top. Alright? Okay, let's try another example. Number 5. What if I had y times x minus 2 minus 3 times x minus 2? You see a factored form of this one? You see what's common, right? You notice that x minus 2 and x minus 2 are what's common. So I can factor them out as a one common factor. So factoring them out basically means that they're gone, right? So this is gone and that is gone. And you're left with what? What are you left with? You're left with y minus 3. So the other factor is y minus 3. There goes your answer. Alright, now let's try another problem. It's slightly tricky. It's a little bit trickier than what we've been doing thus far, but I'll show you how to address that kind of problem. Okay, so number 6, what if we had k times m plus d minus n plus d? Okay, now how do we do something like this? Now, m plus d is common to both sides, right? So you can notice that m plus d is common. You have an m plus d here and an m plus d here. So I can factor them out, right, as 1. So when I factor them out as 1, is as though I divided these two terms by m plus d, so they're gone, right? So I'm left with k. Wait a minute, I have k here. What on earth is left here? There's an invisible number here. So anytime you don't have a number, the default number that you can always put there is 1. Okay, so there's a 1 right here. So if you don't have a number in front of the parentheses, always just put a 1. And that will always work out for you, right? So minus 1 is what I will factor out here. So it's going to be times k minus 1. All right? So there goes your final answer. Now let's try another example similar to this to see if we can get it right. So number 7, what if I had 3x times b minus 4 plus b minus 4? Alright, you notice I have a coefficient here in front of this quantity, but I have nothing here. So what is the invisible number? Invisible man. I'm just going to put a 1 there. Okay, I'm going to put the 1 right here. So when I factor out b minus 4, I will have a number there to combine with 3x. Okay, so then put the 1 there. Alright, so now let's look at these two terms. Is there a common factor? Yes, the common factor is b minus 4. b minus 4 is a common factor, okay? So I'll factor both of them as 1, b minus 4, and what am I left with? Since I factor them out, it's all divided by them, so they're gone, right? So I'm left with 3x plus 1. So parentheses 3x plus 1 is your other answer. Alright, so there you have your final result. Alright, so thanks so much for watching this presentation. Please subscribe to my videos for more updates. I'm going to be making more factoring problems to make sure you really master this process. So subscribe so that you can be updated to the developments on my YouTube site. And then feel free to share this video with your friends if they have issues. And then please like the video if you liked it. If you don't, you can send me an email so that I can address whatever concerns you have. All right. And more videos you can see at mathgoodserve.com. Thanks again and have a wonderful day.